Welcome to today's session where we will be discussing the low-level design of a Splitwise system, an application that helps users split expenses in a fair and transparent way. In this session, we will break down the design of a typical bill splitting system and how we can model it using object-oriented principles and design patterns. We will go step by step, starting from understanding the problem to creating a scalable, maintainable design that you could use in real-world applications. Our goal today is to break down the system of a splitwise-like application, focusing on the core functionality and system architecture required for users to add, manage, and settle expenses. By the end of this session, you will have an understanding of how to design such a system using object-oriented design and design patterns. You will also gain insight into managing data consistency, scalability, and how to implement logic for depth simplification. Additionally, we will explore some best practices for system design, ensuring that the system remains flexible, maintainable, and easy to extend. Let's start with requirement gathering. This is the foundation of any design process. Before we jump into the design itself, we need to understand what the system is meant to do. A splitwise-like system is primarily designed to allow multiple users to split expenses. So the basic functionality includes adding an expense where one user pays and others contribute their share, viewing balances so users know who owes whom and how much, simplifying debts to reduce the number of transactions between users and make it easier to settle up. Additionally, we need to consider edge cases such as handling deleted users, multiple currencies, or partial payments. For instance, should we allow users to add expenses in different currencies, or should the app handle currency conversion automatically? Also, what happens if users leave the group or the system? These are the types of questions that help refine the design. Now that we have a good understanding of the problem, let's move on to entity identification. In any system design, identifying the core entities is crucial to creating an effective design. In this case, our primary entities are user, which represents an individual user in the system with attributes like ID, name, and email. Group, a group of users who can share expenses. A group can have many users, and each user can belong to multiple groups. Expense, a single expense entry which records details about the amount spent and who contributed how much. Split, how an expense is divided among the users. Equal splits, exact amounts, or percentage based splits. Balance sheet, a central component to track the financial relationships between users, that is, who owes whom and how much. Understanding these entities and their attributes helps us map out the relationships between them. Next, let's look at the class design for each of these entities. In a good object-oriented design, classes should have clear responsibilities and the relationships should reflect the problem we are solving. Here's how we would structure the classes. User class contains attributes like ID, name, and email. It is a list of groups the user belongs to. Group class represents a group of users and keeps track of expenses within that group. Each group can contain multiple users and expenses. Expense class represents an expense with properties like the amount and the date. It also includes the split types equal, exact, or percentage. Split class. This class represents how the cost of an expense is divided among users. It can handle different strategies for splitting equal, exact, or percentage splits. Balance sheet class. This class tracks the financial relationship between users. It maintains a record of who owes whom and how much. This breakdown ensures each class has a single responsibility and maintains a clean separation of concerns, which is critical for scalable design. Let's now discuss the relationships between these classes. These relationships define how objects of different classes interact with each other. User to group. This is a many-to-many relationship, meaning each user can belong to multiple groups and each group can have multiple users. Group to expense. This is a one-to-many relationship. Each group can have many expenses, but an expense is always tied to a single group. Expense to split. This is a one-to-many relationship where an expense can have multiple splits. Each split assigns a portion of the expense to a specific user. Balance sheet. The balance sheet holds a many-to-one relationship with both the user and the expense classes, tracking balances between users and ensuring that debts are properly recorded and simplified. By clearly defining these relationships, we ensure that each class interacts in a straightforward, predictable manner. Here's a sequence diagram for adding an expense. The process begins when a user adds an expense to the group. The system then creates an expense object that stores details like the amount and the users involved. After that, the system updates the balance sheet to reflect the updated debts between users. Finally, the system may return the updated balances for users to review. This flow ensures that expenses are added correctly and the financial relationships between users are maintained. When a user wants to view their balances, the system requires the balance sheet to retrieve the outstanding amounts each user owes or is owed. This helps users keep track of their financial status in real time. It's important to note that balances are updated dynamically, meaning users always see the latest state of their debts and credits. The settling up process begins when one user decides to pay off their debt. The system updates the balance sheet to reflect the new payment and reduces the debts between users accordingly. If a user owes multiple people, the system may reduce multiple debts, simplifying them where possible. After the transaction is processed, users can view their updated balances to see how their debts have changed. Now let's talk about error handling. In any system, there are always potential edge cases, and we must ensure that the system behaves robustly under all conditions. Common errors include negative amounts. We don't want to allow negative amounts for expenses or splits. User not found. What if a user tries to add an expense involving someone who's not in the group? Invalid splits. A split that does not sum up to the total expense amount. To handle these cases, we define custom exceptions like invalid split exception or user not found exception. We can also perform validation before performing any calculations to avoid issues. In terms of design patterns, we are using several patterns here to make the system more flexible and maintainable. For example, the strategy pattern is used to allow different types of splits: equal split, exact split, and percentage split. Each split type can be handled by a different strategy. The factory pattern allows us to dynamically create split types without knowing the exact type beforehand. We could also consider using the singleton pattern to ensure that there is only one instance of the balance sheet, making it globally accessible across the application. These patterns provide flexibility, reusability, and better maintainability. For your mini project, your task is to implement the core classes and their interactions. Specifically, you will need to implement the user, group, and expense classes with their attributes and methods. The split class with the different splitting strategies. Key methods like add expense, show balances, and settle up. For those looking for extra challenge, try to extend the functionality by implementing a CLI for user interaction, or even better, unit tests for the various methods you have implemented. To reinforce your understanding, your homework is to implement the complete system and test it thoroughly. In addition to what we discussed in class, try to extend it by adding a depth simplification algorithm which minimizes the number of transactions required to settle the debts between users. Think about how you could represent a settlement graph and simplify debts accordingly. We have covered a lot today. Now I would love to hear your thoughts. What challenges did you think you would face if this system were implemented in a real world scenario? How do you handle multi-currency support? Or what additional features could you think of to make the system more user friendly? What changes would be necessary if we had to implement a mobile app version of this system? Let's open the floor for any questions or discussions, and thank you for your attention.